Okay, so we're going to begin section 3.3, proofs with parallel lines. Essential question: for which of the theorems involving parallel lines and transversals are the converse true? Think about that word converse. We learned that in chapter 2. We're going to be using that in this section. So we're going to use the corresponding angle converse, and we're going to use the transitive property of parallel lines. Properties of parallel lines. Remember yesterday we learned if two lines are parallel and cut by a transversal, then the corresponding angles are congruent. Well, today we're writing the converse. So the converse, if two lines are cut by a transversal so that the corresponding angles are congruent, then we can say the lines are parallel. So we can say, if we don't know, if we're not given this right here, we can say, well, 2 is congruent to 6. Therefore, J is parallel to K. That's what the converse is going to do. We're going to do the opposite. Same for alternate interior. If two lines are cut by a transversal so the alternate interior angles are congruent, then we can say the lines are parallel. So now we're starting out here. 5 is congruent to 4. Therefore, J is parallel to K. We're working backwards. The alternate exterior angle converse. If two lines are cut by a transversal so the alternate exterior angles are congruent, then the lines are parallel. So if we say 1 is congruent to 8, then J must be parallel to K. Yesterday we said if J is parallel to K, then 8 and 1 are congruent because they're alternate exterior. This section we're working backwards. Consecutive interior. If two lines are cut by a transversal so the consecutive interior angles are supplementary, then the lines are parallel. So if the consecutive interior angles add up to 180, then J is parallel to K. Next we have the transitive property of parallel lines. And what that basically says is, if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q, and Q is parallel to R, then P must be parallel to R. So if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q, Q is parallel to R, then P must be parallel to R. Example 1. Find the value of x that makes M parallel to N. So I don't know if M and N are parallel. The only way I know for sure is if these corresponding angles are congruent. So by the corresponding angles congruent converse theorem, we can say that if 65 is equal to 3x plus 5, then M is parallel to N. So what they want us to do is find the value of x that makes that true. So I'm just going to solve for x. 60 equals 3x, divide by 3, divide by 3. X equals 20. When x equals 20, this becomes 65. If this is 65 and this is 65, the corresponding angles are congruent, Therefore, M is parallel to N. Example 2. The flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So that's where we're going to use the transitive lines, the transitive property of parallel lines. So each stripe is parallel to the stripe immediately below it. Let me find a color here that's going to highlight better. So we have S1 is parallel to S2. Then we have S2 is parallel to S3. S3 is parallel to S4. So S1 is parallel to S2. S2 is parallel to S3. S3 is parallel to S4. And we continue on and on and on. So if I look at this, here I have S2 is parallel to S1 and it's parallel to S3. Therefore, S1 is parallel to S3. And I'm going to have the same thing with the rest of them all the way down the line. Here I have, if we continue on, S4 is parallel to S5. S5 is parallel to S6. So by the property of the transitive property of parallel lines, each one of these will continue being parallel to the one. Every other one will continue being parallel. So here I have S3 is parallel to S2 and parallel to S4. Therefore, these are parallel. Then I have S4 is parallel to S4. Therefore, S3 and S5 are parallel. So they're parallel to each other because every line is parallel to the line below it. Example 3. Each step is parallel to the step immediately above it. The bottom step is parallel to the ground. Explain why the top step is parallel to the ground. So this is exactly the same thing. We have the ground down here. And so if the bottom step is parallel to the ground and each step immediately above it is parallel to that step, we know that the steps are parallel to each other all the way up to the top. And if they're parallel to each other, then we know that the step at the top is parallel to all the other steps in this order, including the one at the bottom. And if it's parallel to the one at the bottom, then it's also parallel to the ground. In the diagram below, P is parallel to Q, and Q is parallel to R. Therefore, we know P is also parallel to R by the transitive property of parallel lines. So we need to find the measure of 8. Explain our reasoning. So if they're all parallel to each other and they have a transversal S cutting through them, then let's start looking at some of our theorems we learned about parallel lines cut by transversals. So if this is 115 and P is parallel to Q, this is corresponding. And if it's corresponding, they are congruent. So that is 115. If Q is parallel to R, and this is 115, then the corresponding angle is 115. So now I have this right here that I'm looking at. 115 and angle 8 are on this transversal. Therefore, they form a linear pair. So I can say 115 plus the measure of angle 8 equals 180. So if I subtract 115 from both sides, I get the measure of angle 8 equals 65 degrees. So we have our recap. We are doing the converse of everything we learned in 3.2. So we're just doing the opposite. So these 4 go right along with the 4 we learned in 3.2. We're just working backwards. We're given the angles, therefore we can say the lines are parallel. We had transitive property of parallel lines. If 2 lines are parallel to the same line, then they're parallel to each other. And that wraps up section 3.3. So go ahead and fill in your guided notes and have a great day.